Hey everyone, it is Saturday morning and it's like 14 degrees outside, but that's okay because I've got a Roland SP-700 that needs some attention and I've got a nice fresh brewed cup of coffee. So this will be a fun project to repair. This has been on my to-do list for a while. I bought this well over a year ago. It was just an eBay find. I paid next to nothing for it. I'm trying to remember the story behind it too. I want to say it worked, but then I got it and it didn't. I mean, even the picture of it showed it on, but I powered it on after I got it, and it was absolutely dead. But again, too, it was shipped terribly, so it got all beat up in shipping. There's a big dent in the back, and some of the ears took some hits and stuff like that. So I think I contacted the seller and got some money refunded. I didn't pay very much for it anyway. It was like 40 bucks, so it wasn't a big deal. But I do want to get this working because it is a cool piece of gear. The SP700 is a sample playback player, so it's essentially a sampler without any method of actually sampling. So it's strictly used for playing back samples at high quality, at least for the time. So these were popular for studios a lot, and even people on the road, things like that, where you didn't need the cost of a sampler, or if you needed multiple, to have a lot of samples playing back, and you didn't want to invest in multiple SP750s, which was the close sampler, the actual sampler to this, and just strictly wanted playback functionality. This is also a popular unit because the quality on it was very good. The output section on this was very closely similar to the JD 900, I believe it was. So it's got probably Burr Brown PCM 67s in the output. Should be a discrete one for every stereo pair. So we'll take a look at that once we have it open. But I want to take a look at this because I'd like to get it working. So we'll take the cover off and see what's going on. Somebody's definitely been in this before, I can tell, because there's a handful of screws missing. And of course there's the obvious hack that someone's done on the front. There's something rattling around in here too. I think there's probably a switch or an LED or something that was there, I'm not sure. So somebody's done something to this. We'll find out once we look at it. So here's the power supply, and there's no fuse, so that's why obviously it's not powering on, but there's always a reason why the fuse blows. So it looks like there's a couple capacitors in here that look awfully crispy as well. So we're gonna have to pull this power supply and take a closer look at it. Before I do anything else, let's just see. I threw a fuse in there, and I'm going to power it up slowly, so to make sure that I'm not just going to blow the thing up again, blow the fuse. So if you work on any type of gear, these are probably the most important pieces of gear you can have, especially if you're working on amplifiers, where you can slowly increase the voltage, isolate it, in an isolated fashion, and then watch the current as well as you power it on. So we'll watch the current as I slowly increase the voltage. And as you can see, the current's it's already at an amp, so it's climbing instantly, just at probably a couple volts I had input there. So obviously there's something serious with that power supply, so we need to pull it and take a look at it. Here's the power supply removed. So this was the era that Roland started using switching supplies for some of their gear, mostly because the current consumption on this stuff became really high. This device, especially in the 5-volt rail, to power everything in here, all the DRAM, all the logic, it probably pulls a couple amps at 5 volt. I wouldn't be surprised. So that kind of starts exceeding your standard 7805 regulators in terms of what it can provide in terms of current. So they start going to a little bit more robust switching power supplies with that. With that, I personally hate switching power supplies in terms of working on them because they're always a pain unless it's something simple. But the things I found looking at this aren't terrific. As you can see right here, there's been all sorts of bodges done, repair work. It looks like, if you look at this bank of capacitors right here, there's 3 of them, and they are all crispy. They're all black. So this should be like orange or green. So those are probably already been replaced once before by someone, and they cooked again. You can see traces are here lifted either from soldering, somebody soldering poorly, removing these and putting them back on, or from the actual damage of components getting hot themselves. So I'm not sure. And if you look around too, you can see a lot of flux marks on these traces, or on these where the pins are coming through, indicating to me that somebody's been debugging this quite a bit before. So not a good sign. I'll take a look at this anyway. I'll start just by checking on the input section because that's where the short is. It's drawing current almost immediately from the input, indicating that at least on the front side of this, on the half of the primary side of this transformer, something isn't right. So we'll start looking there and just dividing and conquering. So I'm not making a ton of progress with this power supply, unfortunately. On the input side, I've lifted and removed pretty much anything that I could see that would be potentially causing high current draw right away on input, causing the fuse to blow. And everything's fine. I tested every semiconductor too. They're all fine. All the transistors, all the diodes, all these other FETs in here. the combo choke and the input's fine. Capacitors are fine. You know, all your X series stuff that are designed to not short, you know, upon failure anyway. Everything else is not obviously bad. So that's why I hate switching power supplies. They always kind of suck to work on. You know, because you run into issues where you've got, you know, these hybrid devices in here that handle a lot of the switching. They're proprietary. This power supply is made by TDK2, so the schematic for it's not included within the service manual, unfortunately. So I'm going to pause on the supply for a bit, and I'm going to focus on the actual unit itself, because I want to power this up separately just with a bench supply and make sure it actually works. Because if this thing's dead and toast anyway, like if this power supply failed catastrophically, it could have taken out the whole unit. So I want to make sure this works before I waste any more time on the power supply. And if this does work, and I can't find anything else, just a little bit more troubleshooting, I'll probably just replace the supply. But I'm not going to replace it with the original TDK one here, because it's probably going to be impossible to find. And if I do find it, it's going to be super expensive. So they have the specs on this right here, so you can see it's 5 volts at 2.3 amp, which is not that much. And then you got plus and minus 15 volts. These are very common voltages for power supply, especially for any type of audio gear. Because all your op amps and DACs typically use the plus and minus 15, then your 5 volts used for all the digital logic. So you can use any supply that provides those 3 voltages out. So as long as you've got room to fit it in the actual case, which I've got plenty of room in here, even if I have to get a slightly larger supply, I can put that in here. So that might be the route I go, but let's focus on powering this up first before we do anything else. So here's the main board. Looking at it real quick, the service manual is available for this again. I think I mentioned that, which is nice. So you can, it makes troubleshooting these a lot easier if you do have any type of issues, you know, from the digital logic sections or the analog sections in the output board, which is underneath this board in this shielded metal enclosure. So just quick overview. You got standard 30-pin DRAM in the back here, and it's fully populated. And looking at these should be 4 meg modules. So this is fully populated with 32 megs of RAM, which I think is the max, which is cool. All the other chips and logic on here are all Roland proprietary, and that's typically what Roland would always do for even probably up to date. I mean, they're all their own silicon, which is good and bad. It's good for them. It makes it difficult to troubleshoot because you really don't have much information on any of these chips other than what the data sheet provides. I'm sorry, the service manual provides. Besides that, you got your 2 EEPROMs here for your actual software that runs the unit, and then you got a flash chip here which stores obviously a lot of your settings and stuff like that. This front section is your power supply for the high voltage power supply for the backlit EL display. And I was looking at this too. Here's that switch I mentioned that was in the front panel that somebody wonderfully hacked in there. My guess is it looks like they have it set so they could probably dim the display or turn the display backlight off completely. Maybe they had some situation where they didn't want it on, or they knew these things go bad over time, so just added this in to turn it off, just to extend its lifetime. But either way, I hate when people drill holes in the front gear. It just makes it look terrible, but we'll deal with that. And that's really it. There's not too much to this, so I'll work on getting 5 volts wired up to this and just see if it'll actually power on 5 volts. We should just need 5 volts to get the logic portion of this and display working on this if it actually works. I'm almost guaranteeing the display on this is going to be dim though, in terms of just due to its age. So before I go any further, I just want to make sure it appears this guy is working. I've got it powered up with 5 volts right now. You can see just off frame there, the display is still dead. The backlit lights up, but there's no text on the display. So just quickly probing around this guy, you can see on the scope there that all the data and address lines pretty much anywhere on it are active. And they're not just frozen. It's not like it just froze up or something like that. It is working. I checked all the crystals too. There's like 5 or 6 different oscillators in here for all the various components or various sections. They're all working too. I checked the EEPROMs. I pulled those out against. I downloaded the latest versions, which this has. Did check, and they're fine. So I know those are good too. So all signs of this point to it working. It's just a matter of no display on the LCD here. So that's going to be the next thing I look at. And there is data to the LCD too, so I know that at least it's getting there. I'm probably just missing something, so I need to look at this a little bit closer for another second here. So looking back at the schematic, I was wrong. I missed something, so I was right. I guess that I knew I was wrong. This does need the plus and minus 15 volts for the actual LCD to function. Because it's a digital dimming circuit, there's actually an op amp in there that drives the voltage for that circuit on there, which comes from, I believe it was the negative 15 volt rail. So because of that, I need to provide all 3 voltages, which I can do easily. So doing that now, powering it up, you can see it actually comes alive. So it works, which is good. So just watch it boot up here. The next issue I'm seeing is that it kind of gets stuck on this screen. So it's sitting here for just, I believe, wave memory check. I believe this is where it actually checks to see how much memory is in the unit. It may do a memory test as well, I'm not entirely sure. And then the SCSI device check. It just sits here at SCSI ID 0. So I don't know if it's getting hung here or here, but I have an idea that I want to try that I believe it might be related to the SCSI, SCSI ID. So the SCSI implementation on these is very, very basic. You know, it's all done in hardware, basically, and it doesn't have any advanced features like if termination is not there, you know, ignore. It's like on these devices, typically if termination is missing, it will halt. And if you look back here on the very back, there's SCSI termination resistors that should be in these two sockets right here, just barely in frame, and they're not populated. So I'm guessing if it is getting held up on the SCSI ID check here, that it's because it's not happy with the SCSI bus. I could plug in a SCSI device terminated or just plug in resistors. I've got the resistors, so I'll just plug them in there and see if that makes a difference. So here are the resistors, just two SIP inline packages. I believe these have a common terminal on the end of each one. So we'll plug these in. So orientation on these does matter, because I believe that pin 1 is what ties all the resistors in these together. And let's try powering it up now. Alright, power's on. There. The SCSI ID is incrementing, so that was the issue. So when it hits 7 here, it should be happy. And it is. Awesome. Cool. So the good news is, too, is now that it's working, I can finally adjust the LCD contrast, make it a little bit more legible. So, awesome. Cool. So at this point, as far as I know, it is working. Again, I haven't tested the audio outputs. If this is working, there's a good chance that the DAC board and everything there is going to be fine as well, but we'll test it too. So the LCD, the backlight's still dim on this. I'll probably just replace the backlight actual module in there versus the whole LCD. I'm not sure yet. I'll look at that. I'm not sure what I'm going to do, but we'll talk about that later in the video. But the next steps will be really to go back and address the power supply. Now that I've got confidence that it looks like this unit is going to work, that the power supply didn't take out anything serious, you know, on this board, I'll figure out what I'm going to do with the power supply next. Okay, I got some more coffee. I worked on the supply some more. I'm not happy with the supply in terms of being able to repair it. So I'm pretty convinced it's either this hybrid module or it's something with the transformer. I don't know how many, you know, ohms each winding on this should be. It could be an internal short or something. I'm just not sure. So I looked around and I have this. So this is another power supply that I picked up on eBay a while back. Has exactly what I need, plus or minus 15 volts, plus a 5 volt out, plenty of current. It's a good quality supply, made in Japan. It's going to have clean outputs. And the best news is it fits. Just barely, but it fits. So it'll slide in there. It's out of frame a little bit. It'll slide inside the device here rather nicely. So I'm going to use this. So it might be kind of a sad thing because I'm not really fixing the unit with this supply, but I don't care. These aren't expensive to buy if you get them. I usually buy them as I find them. I'll buy 2 or 3 at a time. I actually forgot I had these. I bought these probably a year ago. I think I only paid like $25 a piece for them. So if you're going to go this route and use an external supply, you know, from eBay or something like that, make sure it's a good supply. Make sure it's made in Japan or anywhere but China. Those cheap Chinese supplies that you see, a lot of times will be as cheap as like $10 or $15, and you can find them in the voltages you need. Just I don't trust them. I've bought some before and looked at them, and they just use questionable components. All the UL stickers on them are just fake. Like they're just fire hazards and not good. So if you're going to do it, I just recommend getting a good Japanese or other country of quality base supply. So I'm going to work on getting this mounted into there. I didn't check to see if the screw holes line up exactly. It looks like they don't, so I'll have to make a little bracket with some plastic or something like that. I'll figure that out. But this will go in, and I will use this to repair this unit. So regarding the display, I want to fix the weak backlight on this so it's brighter and easier to read. And there's two ways you can usually go about doing this. First is you actually just replace the entire display. I buy these from eBay and various places, made by Buy Display, if you search for their website or look for them up on eBay. I've talked about these in many videos before. They're really nice displays. They're LED backlight instead of EL backlight, so they're really bright. They last a long time. I've used this stuff in tons of gear, and they always work very well. And they're inexpensive. These are like 30 bucks. People will often resell these on eBay for like 100, saying they'll work for a certain unit, but don't be fooled. In most cases, you can just buy the actual display itself. So the issue with this one is, if you look at the connector on here, the pins are staggered versus typically they're always straight like this. And that's just more work than I'm willing to deal with for this display, or for this repair, to swap that display out. So I'm probably not going to put the new display in here. The other issue sometimes you have with these LED displays is they are a little bit thicker in terms of their thickness. And sometimes you may not have the clearance between this and the front panel, or you'll have to do some modifications to the chassis so that this sits back a little bit further. But I've talked about this in plenty of other videos too if you're interested. The Kurzweil series I did, the K2000, K2000 or 2500R, uses the same display. So I went over that quite a bit in there. So the other option is just replace the EL backlight, which you can get for these strips. You can buy these strips here. I bought these on eBay. Again, these are under $10 a piece. They're not expensive. People will try to charge you more for them, but if you search, they're out there. You just kind of need to look and be clever on your search terms. So this slips right behind the display, and that's what provides your EL backlight. The only issue with this one, again, is it's kind of non-standard. Is you can see the two pins coming right off here, a little bit further towards the top of the display for the EL backlight that's on this, versus my two pins are kind of centered here. So it's not a big deal. I may just have to run a couple wires over to jumper those there, but that's what I plan to do. Is I'll desolder those, and I'll see if I can sneak this out the back. Usually you can, without having to actually pull the display off of the board itself. So we'll see if that works. So this display has been kind of a weird one. It's the first display I guess I've come across of this particular design, but the issue I'm having is I can't get the EL backlight, which is right here, this little pink strip, out from behind the LCD. Normally they just slide right out, and it's not an issue whatsoever. I've got it desoldered here. I had to remove the bottom connector off of there so we could clear that, and it just won't come out. I think it's glued down. So I pulled the metal bezel off, and my plan was to just remove the LCD on here because it's got the the zebra style strips along the sides, but those are almost like epoxy down too. So I'd rather not risk with messing this display up, because if I do, it's going to be a whole lot of work to replace it with one of those other ones. So what I'm going to do instead is, I've got this disconnected. I'm going to cut off the two wires from that one, and I'm just going to take my replacement strip and just slide it directly in behind like that. So just to test, yeah, get on there. You can see that it's nice and bright now. So that'll work fine. It'll be my solution. Not ideal, but again, it'll work just fine. So while I've all got this torn apart, I wanted to take a look at the audio board on the analog side here, just because I was curious what was in there. And it has a PCM61 made by Burr Brown. So this is an 18-bit monolithic DAC, and this is really one of the high-quality DACs of the time. So I think I mentioned early on, I guess, the 67, but it is a 61. And they are multiplexing the output, all outputs from this, which Roland does typically a lot. So I figured they might have multiple DACs in here, but apparently they didn't need to do that. So all the op amps are older chips made by Signetics. They're NE5532ANs. Those are pretty high quality, at least for the time, operational amplifiers, low noise, typical stuff you would see in this. And then besides that, you've got all your filtering. You got some nice big filters here for the output. Get rid of all your high frequency noise from the converter. And then capacitors are, let's see, these two are ELNAs, which are actually pretty cool. And all the rest are like Nissan Chemicons. So again, Roland typically always uses good quality components in all their gear. No surprises there. Nice panel mounted jacks, and that's it. It's a clean board. Interesting big board too, single layer Single layer board, cheaper to make them that way, of course. Lots of jumpers, but yeah, it's cool to see this. Okay, I've got this mostly back together. Power supply is in, all wired up. Little brackets I made pretty much worked out perfect for holding it in there, and there's plenty of clearance for lid and everything else there. Got the front panel back on, LCD back on. I removed the switch completely since the switch was pretty much broken anyway. I'm not going to use it, and I just bridged that resistor back in that they spliced this wire into, basically. So only thing really left to do is test it here. So let's lift it up a little bit and power it on. Looks good. The contrast is still, I need to adjust the contrast on here. Display is bleeding a little bit because of that, but let's see if it boots up. 32 megs, going through SCSI, looking for any SCSI devices, which there are none. And there we go, it's on. So, contrast, there we go. Much better. Beautiful. So, yeah. I'll have to go through and actually test this now. It's kind of the last stage. I don't have any reason to doubt that it's not going to work. At least respond to MIDI input and provide sound, everything like that. I got to get I'll probably grab one of my old zip disks or jazz drives or something like that and get some samples on there. These read Akai samples too. That's was one of the big selling points of the Roland. So it can read native Akai samples, which is nice. So I'll dig up some samples and give this thing a test. And now with it all back together. So I cleaned up the front, I bent the ears back into shape. The back corner had a big dent in there, I had to fix that, so I kind of pounded that back out so I could get it back together. Cleaned it all as much as I could, and it actually looks pretty good, minus the terrible hole drilled in the front right there. But I'll find something to cover that, even if it's just a small black sticker. It'll look stupid, but whatever. It's better than having a gaping hole there. So, alright, to test, last part. Alright, so here's where I'm at right now. I am been messing around with this for about an hour. I still can't. I'm unable to test it due to SCSI issues. We'll leave it at that. So my S5000, which is my primary sampler I use for a lot of stuff, I tried taking data from that, writing it to a jazz disc, and then importing that disc into the SP-700. The problem is that the drive format between these two isn't compatible. So I formatted one of the discs on the SP-700. And then when I put it into the S5000 to try to actually read that data or write data to it, it basically says that, you know, on the operation not supported with this disk format. So it's not working that way. And it's the same for the other way. If I format a disk on the S5000, it won't even see it. You can see the drive. It'll detect my jazz drive right there, ID4 on the SP700, but it won't actually allow me to do anything to it because it wants to just format that disk again. It can't see the data on there. So that's unfortunate. I thought at least the file system between the two would be compatible. I bet if I were to go get I've got a 3200 XL and a 3000, I bet you if I tried one of those it would probably work. But I'll have to save that for a separate video. I'll just have to do a follow-up video on this where I actually test it. I'm convinced that it's going to work. The SCSI interface on it works. It sees my drives. I can format disks. MIDI on it works. It receives MIDI messages. Everything else seems to be working on it just fine. I just can't verify audio output, unfortunately. But like I said, my confidence level of it actually working is pretty high. So the other issue I had is I've got a bunch of old Roland sample CDs, but of course my one SCSI CD-ROM isn't working for whatever reason. I haven't used this for 8-9 months. Plugged it in, and it won't even detect. So nothing's even seeing it. So I got to look at that. Again, follow-up video for that to see if I can actually test this thing and get it going. Because I've got a ton of Roland samples that I love to just load up on a drive and stick on this thing. And same, it'd be great just to get all my other collections of samples and just have them on a drive where I could use it off this Roland. But unfortunately, it's not going to happen today. So this will pretty much wrap this up. Repair wasn't obviously too complex. The power supply was the problem. It wasn't even a repair, I just replaced it. But it is what it is. It was neat taking a look at this device anyway. A cool old piece of gear, and I'm happy to have it in my rack. So I'll be working on actually getting some testing done with it here. So anyway, thank you for watching.